Hello, good morning. I am Professor Panchabhai from KK College of Engineering, Nashik. Today I am going to discuss about one more topic related to theory of machine, that is synthesis of mechanism. Okay. So what is synthesis of mechanism? Synthesis of mechanism is nothing but to design or creation of a new mechanism on the base, so that you will have a new output motion on the basis of a given input motion. That is synthesis. This is a process of designing or creating a mechanism from the given input to obtain a desired output motion. So for that, what are the requirements are there? The design of mechanism is divided into three parts. The synthesis part is going to be divided into three parts. What are the three parts? First one is type synthesis. Okay. Second one, a number synthesis, and third one is a dimension. These are the three parts in which we have to design a mechanism on the basis of a given input motion. So first of all, a type synthesis. Type synthesis means what? You have given input mechanism, given input motion, and on the basis of given input motion you have to obtain a desired output motion. And for that we are supposed to define, or we have to select either this output motion has to be obtained, or this output motion is going to obtain from, whether it has been obtained by the 4-bar mechanism, or single slider mechanism, or a double slider mechanism, or a simple mechanism, or a complex mechanism. That I have to decide, and that on the basis of that I have to select the type of mechanism, whether my given task, whether my given output has to be obtained with the help of which type of mechanism, and that comes under the category of a type synthesis. Then next one, once you have selected that which type of mechanism is going to satisfy your need, then we have to decide in that mechanism how many number of links are there supposed to be there, how many number of joints are there, whether the links are binary links only, or a ternary links are, or there is any quaternary links are there, a number of joints are there, how the joints are going to be attached over there. There is a ternary joint, quaternary joint, or a binary joints are there. Along with that, how the pairs are will be there, whether there will be all the pairs will be the lower pair, or there will be a presence of a higher pair. That we have to decide under the category of a number synthesis. And last one is after you have decided a type of mechanism, you are selected, then how many links are there, and then we are going to select or define or design the length of the link which is going to satisfy the required output motion characteristics. The next part is structural error and a mechanical error. First of all, structural error. What is my structural error? It is the difference between a desired motion and actual motion produced. Okay, so we know that we have designed a mechanism on the basis of what is your desired motion is over there, but after designing also, that particular mechanism will behave or will follow the desired motion. No, there will be a somewhat gap between the desired motion that we have want to be achieved, but and followed by the an actual path traced by the mechanism that you have designed. So there is a difference between the desired motion that we are willing to happen and what actually the mechanism is going to follow. That difference is called as a structural error. Next one is mechanical error. This error presents due to the manufacturing processes. During manufacturing, there are a lot of errors are going to be happening in the while manufacturing the parts, and this manufacturing error is going to be occurring or is going to be results into the mechanical error at the end of, because of the some tolerances in the length of the link, or there is some clearance in the length of the link, and this total results of all this total is occurring in terms of or is called in terms of known as a mechanical error. Next point is precision point. Okay, so this is a figure where you can see that along the x-axis there is x input, input motion is given, along y-axis there is output motion. I have to trace. X1 is the first point. For that, y1 is the point has to be located. When the input motion has moved to the point x2, a linear displacement, y output motion has to be gone for a point at y2, and so on, x3, x4 and x5, and similarly y3, y4 and y5. Okay, So it means that for a input motion, when the input motion will follow when the input motion will run, there has supposed to be y, that is output motion has to follow in this fashion, and your desired function is that it is going to be a straight line. Okay, this is your design function, or design function is over there. Okay. But after you have designed a mechanism, there is no guarantee that it is going to trace a similar path, that is a straight line starting from 0 point and meeting all the points. It is not possible. It is going to trace a path like a zigzag way, this way. Okay, that is the generated function. Okay, or actual motion that you are getting from the mechanism, that what you have designed over there. So but you can see that the desired function and generated function are getting overlap at some of the points. Okay, and these points are called as the precision points, or accuracy points. The points where the generated function and a desired function are same, are having the same values what you actually want to achieve, and what is actually what you want to achieve has been achieved by the generated function. So that points are called, these points are called as precision points. Okay, means for x1 point, what you want to achieve from the desired function, x1 value should be equivalent to the y1. When the x1 value for the input, then supposed to be there is a y1 value of function that we want to achieve with the help of a desired function. So that can be achieved with the help of a generated function also. So x1 is a precision point. Next one, for at a value of x2, your y2 value is supposed to be over there. By this zigzag path also, that is a desired function or desired motion, you can achieve the point y2 value when you require it from the x2 input motion. So these are the point where you are getting these values are exactly matched with the desired and generated values. These are called as a precision point. Generally we require, and these precision points for the first trial method can be achieved with the help of a Chebyshev spacing equation, which is given by over here, that is xj. The j represent the precision points where there is a first precision point, second precision point, or so on. 1 by 2 is equal to 1 by 2 xs plus xf, that is starting point and finishing point, minus half of xs, difference between the starting point and finish point, into cos of pi into 2j minus 1. Over here I have made a mistake, that is the final point is supposed to be on a right left side, and small values of xs is supposed to be on the right hand side. So difference will be the positive. It's nothing but a range between them, into cos of pi into 2j minus 1 upon twice n, where j is represented the precision points and xs and fs are nothing but a start and finish position. Okay, where you want to achieve in this figure, you can see this is the starting position and this is the final position. So this is the range, this is the start point 0 point and 5, this is the last position. In between that, what are the different precision points what we have to achieve? This point precision points can be find out with the help of this Chebyshev spacing equation. Okay, this is one of the equation by which you can obtain a precision point, or you can find out the precision point. Similarly, this is the mechanism ABCD, you can see that. Okay, if this initial position of a mechanism AB1, okay, and similarly as AB is moving anti-clockwise, CD is also following, that is this is the AB is the input motion and CD is the output motion. That will what you want to achieve from the given mechanism. Then B1 is the initial precision point, and B2 is the final point of the link AB. So AB is making an angle of theta s with respect to the point A, and theta f is the AB2 is the angle made by the theta f, final input angle and starting input angle. And AB or B point is nothing but a precision point in between the motion from B1 to B2. That B point is one of the precision point present between the starting point and finish point. Okay. Similarly, C1 is the starting point making an angle of phi s, that is output starting angle, and C2 is the phi f, that is the output final angle or the finish angle, that what we require for a link CD. And in between input values, in between the starting point and finish point, there is a C point. That point is called as a precision point. So for angular calculation or for angular relationship for a function generation, how you can calculate the values of input values from the given starting and finish point that can be calculated with the help of this once again Chebyshev spacing formula, that is theta j equal to theta s plus theta f, that is a final input angle minus starting input angle upon xf minus xf, that is the starting finish starting linear displacement of a final point, finish linear point minus xs, that is starting and finish point, into x, the point at which you have to the precision points, where what is the value of this x represent the precision points value, minus xs. And similarly output value phi j, as theta represent me for the input value angle and phi represent me the output angle. Over here you can see that this is the starting point, this is the end point, and this x represent me what, a precision point. So for xs there is a theta s, and for xf, when the mechanism had moved from x value, xs value, it is going to have a theta s angle. When it is moved to the void xf, finish xf value, it is having a theta f value. And in between that, if I want to find out the precision point, that is x point, and for that the input angle is theta. So this theta can be found out with the help of this formula. And similarly phi j can be found out with phi s plus phi f minus phi s upon y f minus y s in bracket y minus y s. Okay, this is the angular values which are supposed to find out for the given input and output link. Now consider one problem, a 4-bar mechanism you have to design by using 3 precision points to generate the function y equal to x raised to power 1.5. This is the function generation is given to us. What function will be followed by the output angle with respect to the input value for the range x1 is less than or equal to x is less than or equal to 4. Assuming 30 degree starting position and 120 degree finishing position for the input link. These are the angles for the input link, and 90 degree starting position and 180 degree finishing position for the output link. Okay, so these are the output starting point and output finish point that is being given. Find the values of x, y, theta and phi corresponding to the 3 precision points. Here it has been mentioned that there are 3 precision points you have to find out between the range 1 and 4 for the x value, where y values are correlated with respect to the y value function with the function y equal to x raised to power 1.5. So give from this problem statement, what are the given data is that the starting point for x, that is 1, finish point for x, that is 4, sorry I have written 1 over there, and theta s, that is starting input angle 30 degree, output finish input final angle, that is 120 degree, input output start angle 90 degree. It has been make a mistake, it is a 90 degree, and phi f equal to 180 degree. On the basis of that, we have to find out a solution, that we have to find out the values of x, y, theta and phi for the respective 3 precision point that has been discussed in the problem statement. Now solution, there are 3 precision points are there. We know Chebyshev spacing equation, that Chebyshev spacing equation is equal to xj equal to half of xs and f plus xf minus half of xf minus xf into cos of pi into 2j minus 1 upon 2n, where n represent the number of precision points and j represent the respective precision point. If I am calculating value x1, that is a precision point at the position number 1, then half of xs is 1, xf is 4, minus 4 minus 1 cos of pi into 2 into 1. Why 1? Because j, I am calculating the precision point value at point 1. So 2 into 1 minus 1 upon 2 into 3, because 2 number of precision points are 3. That what we have given in the problem statement. On the basis of this, if I done the calculation of this one, the value of x1 is equal to 1.2, and it should be greater than the starting finish point, because your starting point is something 1 and final point is 4. So all the values of precision points are supposed to be lie in between the 1 and 4 only. If it exceed beyond 4 or if it less than 1, it means that you have made some error while calculating the values. Okay. Similarly, precision points number 2, repeating the same formula, all the values are same over here, only the j value is going to be changed. That is a precision point j number, point number 2, 2 into 2 minus 1 upon 2 into 3. This will remain. Otherwise all the values you can see 1 by 2, 1 plus 4, 1 by minus 1 by 2, 4 minus 1, cost function remains same. Only this j value is going to be changed. Along with that, the precision points 2 number, I am getting the value is equal to 2.5. Similarly, third precision points over here, I have just changed the value of 3 point over there. One, apart from that, everything is remaining same. So after calculation, this value is come towards the 3.8. So in this way, I have found out the value for x1, x2 and x3 by using the Chebyshev spacing equation and putting the respective precision point 1, 2, 3. I am getting 1.2, 2.5 and 3.5 in between the range 1 and 4, not beyond that. Now we also know that the function generation function is given to me, what output, how the input and output are correlated to each other, that is y equal to x raised to power 1.5. So on the basis of that, y1 equal to x1 raised to power 1.5. So I am putting the values of x1 value which I have been calculating from the previous slide, that is a 1.2 raised to power 1.5. I am getting y1 value equal to 1.316. When x1 point value will be equal to 1.2, according to this function y equal to x raised to power 1.5, y1 value will be equal to 1.316. Next, similarly y2 equal to x2 raised to power 1.5. I am putting the values of x2 over here. I am getting 2.5 raised to power 1.5. So by default, the value of y2 will be equal to 3.952 with the function y equal to x raised to power 1.5. And y3 value equal to, once again just putting the values related to x3, that is x3 equal to 3.8, you are getting 7.41. Then angular relationship, we have find out the value of linear displacement for input motion as well as linear values for output motion, that is x and y, at the three different precision point x1, x2, x3, y1, y2, y3. Now we are finding out the input angle and output angle at the respective precision points with the help of this formula theta j. Okay, that theta 1 will be equal to theta j equal to theta s plus theta f minus theta s upon xf minus xs into x minus xs. Over here, theta 1 will be equal to 30 degree, that is the starting finish point. Theta s is 30 degree, that is the starting input angle, plus final input angle is 120 minus 30 degree upon final finish point is 4 and starting point is 1, so 4 minus 1 into x. X is related over here, it's a value, you are calculating value of first precision point, so x is related to the xj. So x1 1.2 minus 1. So I am getting the input angle, first input angle at the first precision point, that is equal after starting point, it is equal to 36 degree. Similarly, I am going to repeat the values for theta 2, where I am just going to replace the 1.2 with the help of x2 value, that is a 2.5, which has been calculated previously by the Chebyshev spacing equation, and putting values over here, I am getting 2.5 minus 1 equal to something equal to 75 degree. It means the angle 1 and precision points for the position number 1, that angle will be equal to 36 degree. For second point, angle will be equal to 75 degree, and third point 30 plus 120. Once again repeating the same term, just replacing the value of x with the help of x3, that is a 3.81. I am getting 114. This all the values 36 degree, 75 degree and 114 is are between the 30 degree and 120 degree. Sorry. Then for the output angle, repeating the same procedure, but just over there the values are related to x and theta. Now the values will be related to the y and phi. So first value phi 1 equal to 90 degree, because the starting output angle is 90 degree and finish final output angle is 180 degree. So 180 degree minus 90 upon yf is, how we calculate a yf, y equal to x raised to power 1.5. For that finish value, that is 4 raised to power 1.5, you will have a 8 value. In this way, 8 minus 1 in bracket 1.316 minus 1 equal to 94.06. Phi 2, just instead of over here y1 value, I am putting the values of y2, which has been calculated already in the previous slide. So 3.952 minus 1, I am getting a 127.95. And phi 3, is equal to, just replacing the value instead of y2 we are putting the values of y3 over here, 7.41 minus 1. Apart from that, all the values, all these terms or these values are going to be repeated over here. So I am getting the angle equal to 172.41. So the phi 1, phi 2 and phi 3 are the values 94.06, 127.95 and 172.41. So and all these values are lying in between the 90 and 180 degree. So in this way we have find out the linear values of input function, that is x at the 3 precision point, that is x1, x2, x3. Then at 3 for output function y1, y2, y3, 3 precision point. Then for angle, input angle at 3 different precision points, that is theta 1, theta 2, theta 3. And lastly phi 1, phi 2, phi 3 output precision, 3 output precision points